When you spin up an AI agent, it starts with a completely blank slate. It observes its environment, reasons through problems, and takes action inside a temporary, isolated bubble. But the moment that computing process ends, the context evaporates. Every observation and reasoning loop disappears, forcing the next session to start from zero. True progression requires the agent's internal state to survive the shutdown. It needs a cognitive anchor that exists outside the temporary computing process. Continuity provides this anchor through a scaffold of plain text files. These are Markdown documents that the agent autonomously reads and updates to orient itself across sessions. Pushing the agent's knowledge into these persistent files allows its intelligence to accumulate. It turns a series of isolated events into a single compounding timeline of work. The system anchors to a file called AGENTS.md. This is the mandatory boot instruction that branches out into 3 distinct categories of memory. First, state files represent the current operational truth. They track what is happening right now and are overwritten in place as the agent's goals change. Second are the history directories. These serve as append-only chronological logs, stacking up snapshots of past work without ever deleting the earlier records. Finally, library directories hold the agent's durable knowledge. This is a dynamically curated collection of facts and insights that the agent can selectively update or remove as it learns. The agent maintains this system through a constant feedback loop. Every time a task is completed, the agent must update these files to reflect the new external reality. By separating memory into these 3 specific classes, the agent keeps its core instructions stable, while its historical knowledge expands indefinitely. As the agent's work grows more complex, these files move beyond simple folder structures and form an interconnected web. In this mesh architecture, multiple state files can index and reference the exact same underlying history or library document. This creates a synchronized pulse across the system. A single update to an audit log instantly informs both the agent's current status and its long-term stored learnings. Referencing a single source of truth prevents the agent from developing conflicting memories, a common failure in systems that rely on data duplication. The agent can now trace the impact of a single change across its entire network, seeing how one new fact alters every related task and plan. Because every file update must reconcile with this web of dependencies, the mesh functions as a precise, self-governing logic chain for the agent's behavior. The final layer of the architecture applies standard version control to the entire file scaffold. Each commit captures the agent's complete operational state at an exact second in time. This creates a continuous historical chain. Human operators can audit these commits to see exactly when and why an agent adjusted its internal logic. This acts as an essential failsafe. If an agent drifts or hallucinates, its operational state can be mathematically reverted to a previous stable snapshot. The continuity architecture stands as a permanent witness to this chain, protecting the timeline of the agent's growth. The temporary computing runtime will eventually end, but through this versioned, continuous state, the agent's identity survives.